Our final coordinate geometry unit deals with circles, which we also spent some time on this year. Our targets: I can identify the center and radius of a circle from an equation. I can write an equation of a circle given the center and the radius, so kind of working in both directions. And then finally, I can complete the square to rewrite an equation of a circle. So let's review. I think you might have seen this in Algebra 2. If we have a circle that has a center that's got the coordinates hk and has a radius of distance r, the equation of the circle is x minus h quantity squared plus y minus k quantity squared equals r squared. And hk is the center and r is the radius. Okay? So if we look down at example 1, it says find the center and radius of the circle. It's already in the form where we can see it. So you just need to pick out this h and this k, right? Remember, it's x minus h and y minus k. So my center is 6, but this would be y minus -4. So the y coordinate, of course, is -4. That's the center. This represents r squared, which means my radius would be 9. Easy enough. Question I ask here, what if it would have equaled -81? Is there any way r squared could equal -81? No, right? We cannot have a radius squared come out to be a negative number, so this would not be possible. Your radius squared cannot be a negative number. All right, let's look at these examples we have here on this page. Find the equation of a circle whose center is 2, 8 and whose radius is 7. So this is just going the opposite direction. We do x minus, this is like hk. So x minus h, that's x minus 2. Remember, it's squared plus y minus k, but k is 8. Squared equals r squared, so that would be 49. Again, this was x minus h squared plus y minus k squared equals r squared. That's where we got that from. All right, it says write an equation that represents the circle shown. Here I can see that my center is 0, 0. And looking at the graph, I can see that my radius is 6. So that would be x minus 0 squared plus y minus 0 squared equals 6 squared. A better way to say that is just x squared plus y squared equals 36. So it's a real clean looking equation when your center's at 0, 0. Here my center is at 1, 2. My radius, well, I don't see the radius, but I know I can use distance formula to calculate it. So the radius would be the square root of x minus x quantity squared, y minus y, 6 minus 2 quantity squared. So yes, you can't forget distance formula. That's 3 squared is 9. That's 4 squared is 16. That's the square root of 25, which is 5. So my radius is 5. Once I have that information, I can just use my circle formula. X minus the x coordinate quantity squared, y minus the y coordinate quantity squared equals 5 squared, which is 25. Okay. These last two are going to be the toughest because we're going to have to complete the square, which I know we talked about when we talked about quadratics back in chapter 9, but it's been a while. The tricky part on circles is that you need to complete the square twice because you'll notice we have x squareds and we also have y squared. So I like to do this. I like to write x squared minus 8x and then leave myself a blank to complete the square. And then I have y squared minus 10y, and then I'm going to leave a blank because I need to complete the square on y, equals 8. But if you remember from completing the square, whatever I add to the left, I also have to add to the right. So I'm also going to put 2 blanks here just so that I don't forget to add it to both sides. So I'm completing the square on x, I'm going to add it to the other side. I'm completing the square on y, and I'm going to add it to the other side. To complete the square, you take half the coefficient of x, or I guess, or y. You square it, and then you add to both sides. Whoops, square it, add to both sides. So quick reminder, half of 8 is 4, squared is 16. So I add 16 to both sides. Half of 10 is 5, squared is 25, and I add it to both sides. Notice how it's always going to be positive, because when you're squaring, any negative value would disappear. Half of negative 8 is technically negative 4, but squared is still 16. So we don't have to worry about signs. Then the key is to factor. Completing the square means we're factoring it to a perfect square. This is x. What's squared is 16, but 4. And to get a minus 8 in the middle, we'd have to have a minus. This should also factor to a perfect square. I have y. What's squared is 25, but 5. To get a negative 10, I have to have a minus. And if I add up 8, 16, and 25, I happen to get 49. Now I can easily see my answer. I need the center. The center is going to be 4, 5. And this is radius squared, so my radius will be 7. But you won't see that until it's in complete the square form. So let's quickly go through example 5. It's very similar, except you're going to notice we have 3's in front here. I can't complete the square with coefficients in front of the square term, so I'm going to divide everything by 3 to get rid of that. And when I do that, I'm left with x squared plus y squared plus 2x minus 6y equals 5. Now I want to arrange it much like I had it up here. Notice I had my x's together and my y's together, and the plane number here, this constant, was on the other side. So that's pretty good. But I need my x's together, so x squared plus 2x. I'm going to leave a blank to complete the square, plus y squared plus, or I'm sorry, not plus, minus 6y, and then I'm going to leave a blank to complete the square, equals 5, and I have to remember to add both of these over on this side. So here's my rule. Half the coefficient of x. Half of 2 is 1. 1 squared is 1, but I have to add it to both sides. Half of negative 6, or just 6, is 3. Squared is 9, but I have to add it to both sides. So I factor to a perfect square. X, what squared is 1. To get a positive 2, I'd need a plus. This must factor to a perfect square. Y squared must be y. 9 is 3 squared. To get a negative 6, I'd have to have a negative 3 and a negative 3. And this right here adds up to 15. All right, so I can now see that my center, right, is going to be negative 1, 3. So watch your signs. Here, this, remember, is radius squared. So how do I get radius from radius squared? I would take the square root. So the radius would be the square root of 15. I don't want a decimal. I want you to just leave it like that.